Hello and welcome.
All right. So we want to thank you for coming to see us today at 4 o'clock. We know there's probably many other places to be, but this one is very exciting. We're going to be talking about digital century, digital learning, and we have some really exciting presenters for you today and some great demos. So you're going to want to stay tuned. All right, eyes and ears wide open. So we're going to start off with Dan White. He's the CEO of Filament Games, and we're going to look into immersive environments such as video games. So, Dan White, without further ado.
I'm told I'll get a clicker.
Oh, there is a clicking. Here.
Excellent, thank you. Okay, hi everybody. So as you mentioned, I'm Dan White with Filament Games. Filament Games is a game development studio that develops learning games. In education technology, so there's this long sordid history of education technology not working out so well. So as a result, I think there's a fair amount of skepticism in institutional education and elsewhere. I think everybody else on the panel will probably be talking about a similar struggle in some capacity or another, but essentially, if you're trying to present some sort of new technology within institutional education, you can expect some skepticism and some pushback. Accordingly, any new technology needs to have a good elevator pitch, and I think the elevator pitch for game-based learning has typically looked something like this. Learning is excellent and good and useful, and the problem is that it's boring. However, games, while not good for you, are really fun. So if we can just combine these two things together, we can have our cake and eat it too. I've told my son not to use this word, and here I put it right in my slide, but honestly, I really do think this is a stupid ideology. Number one, learning is inherently fun, right? So we don't need to fix learning with games. We don't need to candy coat it or sugar coat it. And number two is this methodology results in things like this, which is essentially drill and practice or test prep with nice production values, right? So you have a play mechanic and you have a learning mechanic, and they don't have anything to do with each other, and they're just sort of awkwardly sandwiched together. This is my favorite example because I think it's the worst thing out there. It's coolmath.com. Don't be mistaken into thinking that nobody goes to this website because it looks like this. This website makes millions of dollars a year from ad revenue, just ad revenue alone. And you notice at the top it says, welcome to the new Cool Math. What in God's name did the old Cool Math look like? So that aside, yes, games are fun. We all get that games are fun. And yes, that's part of their value. But the real value is that they're experience engines, right? And as Einstein posits so nicely, learning is experience and everything else is just information. Okay, so I'd like to tell you a little story to kind of illustrate this point. We have two students here, A and B, and they both want to build a rocket ship and they want to go into outer space. So A takes the more traditional path of reading everything he can find about manned spaceflight and rocket science. And B plays this game called Kerbal Space Program, which if you haven't played it, is a game where you can design and build essentially any rocket ship you can possibly imagine. You can set it into space, you can experiment with orbital trajectories, and you can learn through trial and error what works and what doesn't. For example, trying to re-enter planetary orbit without a rocket ship is not a great idea. So at the end of this process, I would argue that student A has something we consider knowledge, student B has something we consider understanding, and I put in parentheses above knowledge declarative, so basically anything you can, facts and figures, things that you can Google. Procedural for understanding being the understanding embedded in the performance of a task, right? And I would argue that B is in better position here because understanding is constructed while knowledge is assimilated, right? So when A is reading all these books about manned spaceflight, he doesn't have the context in order to really make sense of the things that he's reading. So accordingly, all this new information is difficult for him to assimilate because he doesn't have mental models that are prepared to accept it. Accordingly, his acquisition of knowledge is kind of a linear slog. But when B hits the books after playing Kerbal, this rich experience that she's had playing the game gives her a really good understanding of what all this stuff looks and feels like. And so when she's reading about it, she's got this mental model that's nicely prepared to accept this information. And over time, I would argue that her knowledge acquisition increases much faster. This is something called preparation for future learning. It's a theory put forward by Dan Schwartz. And the basic concept is that an experience like a game can prepare you for more formal academic study afterwards, whether it's a classroom lecture or reading in a textbook. I would also argue that the order matters for another reason, frustration versus inspiration, right? So linear slogs are no fun, whereas B, student B here in this case, has had early traction with her learning experience, and the whole thing's felt very smooth and motivating. So since the dawn of the learning games industry, right, we've seen this sort of dichotomy. People who recognize that this technology is about designing experiences for people, and people who design the games just to deliver content. So I'll show you some examples of contemporary learning games that I think are best used as experience engines. So this is a game where it's called Crazy Plant Shop. Customers come into your plant shop and they order different types of plants. You don't have these plants, but you can breed plants together using Punnett squares in order to fill their orders, right? Here's another game where you're using the principles of engineering in order to design, catapults. And you're trying to win this backyard water balloon fight, and by understanding and enacting the principles of engineering, you can succeed in the game. Here's a game where you're learning about the principles of Newtonian physics by piloting a spacecraft around obstacles in order to try to rescue these little adorable fuzzy creatures. And that thing that you're seeing down on the bottom there is a little timeline. It sort of acts like a video editor except instead of editing clips, you're actually editing forces, Newtonian forces, over time. Here's a game where you're learning about body systems and how they work by actually manipulating them within a hapless patient and seeing all sorts of awful things happen. This is a game called Reach for the Sun, where you're growing a plant from seed to seed, and you're making strategic decisions about the resources that you gather and the parts of the plant that you grow over the course of the growing season. It's a game where you're understanding how cells work by manipulating the organelles within the cell. Here's a game where you're taking on the role of a researcher in the Northwest Hawaiian Islands and trying to collect data about how the ecosystem works so that you can make a scientific argument about it. Okay, so we've got all these examples of learning games that I think represent not only best practice in terms of acting as experience engines, but also in terms of providing this preparation for future learning that I'm talking about. The other thing that I think contemporary game-based learning can do well is this sort of preparation for future thinking. So if you accept this premise that being successful in your career, your life after school, is predicated on being able to navigate complex problem spaces and solve complex problems, then you could say that something like project-based learning or the maker movement is this really nice on-ramp to that, and that it's those same sort of principles that recruits that same type of thinking, but within tighter constraints and with a lot more scaffolding. So I would then in turn argue that game-based learning is this really nice on-ramp to PBL and maker pedagogies, in that it's, again, navigating these complex problem spaces, these authentic problem spaces, but again, with more scaffolding and more constraints. So the last thing I'll say here is that, if you're sold that this is a great idea, I'll tell you, there's a lot of challenges. I'm going to focus on two of them. If you navigate toward the parent market or the consumer market with these types of products, the problem that you run into is that purchasing agency for parents falls off dramatically after elementary school. If you navigate toward the teacher market or the institutional education market, one of the problems that you run into is that schools are very failure averse, kind of myopically focused on raising test scores. There's a system of punitive accountability, and it's very risk averse, averse to new technologies like this. This is the thing that we're trying to change. This is the battle that we're fighting every day. And if you're interested in game-based learning or trying to help us in this battle or interested in developing your own games to teach things, change behaviors, or improve people's lives, come talk to me afterwards. Thank you.
Sounds good. All right. I'm not sure if he needs it. Well, fantastic. As we start talking about transforming EDU, immersive games, obviously, in the virtual world are a fantastic application, as Dan just showed us. But what about virtual reality? This can also be a very interesting way to engage people and learners. So we have Drew Minock here from DAQRI, and he is the education program manager there. He's going to talk about 4D.
So 4D is augmented reality with some other technologies mixed in with it, something like vision science, for example. And we use this technology to really enhance the learning experience. And like Jason said, I work for DAQRI. And what we do is we are a platform that has products in hardware, software, technology research, and innovation. And a lot of things that we do really base around knowledge and knowledge transfer. And augmented reality has such a great impact on knowledge transfer because our brains are are visual processors, right? They're not word processors. So when I visually see something, your brain really absorbs that information a lot more. And one of our main apps that we have here is called Elements 4D. And there's actually 6 blocks, 4 back there. And each face has a different element from the periodic table. So all you have to do once you fire the app up, let's connect it up there. Doesn't look like it's mirroring. There we go.
All right.
And all I have to do is scan the face of one of the blocks. So we have gold here. And when I scan it, the block turns into gold. I can then touch the word and get more information about it. I can also introduce a second block, like chlorine, which is a gas. So now we have a solid and a gas. And then by simply just taking the 2 physical blocks and touching them together, it gives me the chemical reaction. So the things with this application and what 4D and augmented reality allow us to do is bring things in the classroom that before was absolutely impossible. Okay, something like the solar system you can now hold in your hand in 3D and 4D and explore it that way. And the thing with learning is it's such a different experience than watching a Bill Nye Science video or something like that, right? I actually get to hold the solar system in my hand and explore it. It also allows us to interact with dangerous materials in a very safe way. Schools aren't allowed to have mercury in classrooms anymore. On occasion, we'll run into a science teacher who has some stored in his closet somewhere, but he doesn't tell his principal that. Something like mercury. So I scan it. Something I can't have in the classroom, now I can have right here. I can hold it in my hand. See? Oh, let's get that one up. And I can see how it interacts with different elements. I can send these blocks home, or they can print them out right inside the app, the paper version, and make them for absolutely free. And we've worked with teachers all over the country to create lesson plans for upper elementary, middle school, and high school. And we have teachers all over the world that are using this in their science classes. So this is just one of the educational apps that we have. This up here is the DAQRI Smart Helmet. And this is a major announcement that we just made here this week at CES is our partnership with Intel. And what the DAQRI Smart Helmet is it's the first ever human-machine interface built solely for industrial use. So this isn't a consumer product, but it's built solely for the industrial market. And it's a certified hard hat that construction workers or workers in the industry can use. And it's incredibly powerful. So there's 9 cameras right here, including a thermal camera, along with a camera in the back here. And what you can do is you can see thermal vision is one of the main tools that this has right here. So if you're on a factory floor, you can look out over all this machinery and see if one of the pieces of machinery will overheat using the thermal vision. Something like augmented work instructions. So let's say you're inspecting all these pipes and valves, and you look at it, it will automatically read the gauge to see the air pressure, and if it's too high, it will then put you through a series of augmented work instructions. And what that is it's digital information overlaid right on top of the pipes to walk you through on how to fix that issue. So if you've never done it before, you can fix that issue at 100% using this. Another thing is called Remote Expert. So let's say I'm out in the field and I have this on and I encounter something I have no idea how to fix. I can then do a video chat with an expert anywhere in the world who will see exactly what I see and can anecdote right over the screen, and it will automatically appear right in my view, so he can walk me through on how to fix that problem. And that's just some of the things that this thing can do. And the reason I'm showing this as well is because there was actually an article put out by an education publication yesterday about the top 10 things to see at CES that will impact education, and that was the first one listed. Because this has a huge impact on not just education in the classroom, but the way that we train people and learn how to do our job. So like I said, everything that we do at DAQRI really impacts knowledge, and these are just a few of the things that we do.
Fantastic. Wow. Whew. Well, thank you, Drew. So we've got games-based learning. We've got AR. What about AI? And today we have someone from robotics, from Aldebaran. Steve Carlin is also the walking champion, I think, of CES, walking over 20,000 steps, which is pretty crazy. But from Aldebaran.
So we're waiting on a plug, I think, but he's right. I get a little impatient with those taxi lines. So lots of trips from the Venetian back to the Bellagio and that area. We're really excited to be here today and excited to see you all. I think while he's setting this up, I want to point one person out in the crowd. We have a gentleman here who's one of our distinguished teachers in our program with Now, our robot, Hunter Lloyd. Raise your hand, Hunter. Since we're mic'd up, he can't say a few words, but we wanted to point out to you that he's here because we'd love for you, if you're in the education field, to have a chance to maybe speak with him. Obviously, I'll be here as well, but Hunter's been gracious enough to sit in with us and be sort of the living example of how we might bring Now to life in a classroom setting. Oh, good job, you're the man. All right. So again, my name's Steve Carlin. I'm the global, I am the Vice President of Marketing and Business Development for Aldebaran, a SoftBank robotics company based in San Francisco. And as hopefully you've seen Now is about 9,000 units out in the world in 70 different countries, which is phenomenal, and that's a great base of robots, but it didn't really happen overnight. The original intention for Now was, in the beginning, was started for the RoboCup, and hopefully you've seen this, it's kind of fun. Now it turns out is a tremendous soccer player. The idea behind this whole thing was that in the year 2050, robots could take on the reigning World Cup champions. Now I suspect Herr Schweinsteiger and the German team is not so worried about it just yet, but give it some time, and we're enthusiastic. So in 2008, teams from all over the world have been, since 2008, they've been coming in to compete. And obviously these students are having an awful lot of fun having Now play the game and compete against one another. But really, they're getting some tremendous experience in programming and the understanding of robotics, how robots move and interact in the world. And it goes beyond, obviously, the RoboCup. And you can imagine in a university setting how powerful this could be for an engineering group. This would be an example from a French engineering school, Epitech, where they're actually teaching Now how to drive a car, which I think our friends from the French car companies are excited about. And even for younger cars, or even for younger students, there's the Now Challenge, which is a year-long program that culminates in an event in June where they come and compete against one another. So students from North America, Europe, and Asia all come together, and they actually produce many, many projects over the course of the year, which is phenomenal. Things like a dance party and other small projects. But what we see is that because of its natural interface, Now also gets involved in other aspects of education. So imagine how engaging this tool is in a classroom. So Now it's been used to really gain the attention of students, maybe students that would otherwise have a hard time paying attention and being engaged with the curriculum. In Switzerland, this is actually really interesting. In Switzerland, Now is actually being used as an avatar for children who can't come to school. They might be in the hospital, for example, or they might be homesick for a period of time. And rather than have them lose that time in the classroom and learning, Now can sit in for them, and they can operate Now remotely. And I think what these examples really show is the power of the platform, not unlike gamification that we were just talking about, but these applications weren't necessarily what we had originally planned for. But as you can see, the teachers and educators have taken us on this journey, and they've really expanded past what Now was originally intended to be, which was a companion robot. And now it's being fully used and leveraged in an educational setting. So again, education engagement has become really interesting, not only for people interested in coding and engineering, but also people who wouldn't have otherwise gravitated towards that field. So think about STEM education in the United States, and especially with groups of students that might not normally be encouraged to get into this kind of education. For example, for young women. And Now has been a source of inspiration for people getting into the robotics field. Second, students are experimenting, they're testing, they're learning with this platform, and what that's doing is giving them the confidence to really grow and learn. It's really fundamentally changing in their setting how they go about growing and learning. And so the benefits of all these interactions is really that these students are starting to get control of what technology means to them and how they control technology and where they see technology going and therefore how it impacts their life. And that's, again, a very powerful tool. So now is used from kindergartens to universities. Certainly, we can see it going in lots of directions moving forward. But we're really excited, and again, thank you so much for having us here. We'd love to answer any other questions you have towards the end of the session. Again, Professor Lloyd would be happy to answer as well. Thank you.
All right. Well, thank you, Steve, for that in robotics. That's fantastic. So next we have Arvid Kappas, who is the Vice President of Marketing and Business Development for Emote.
Yes, actually, I'm a professor.
Doctor, right.
Because Emote is a project that is funded by the European Union. It involves partners in Portugal, England, Scotland, Sweden, and Germany. And we are using now what you just saw as a front end for a system that involves many cameras, sensors, information about games to have the capacity to engage children on a social level. And I have a video. Maybe.
That would be my bad.
So that you get an idea what it looks like, because it didn't make sense to bring the robot, because it's about the interaction between the robot and the children.
Actually, I think he's supposed to go this way.
Right.
He's a humanoid.
Okay. They're good back there. They're good. See.
Hello, I am Now, and I am going to be your teacher.
Now doesn't finish work at 5 o'clock. He doesn't know the word stress, and he doesn't ask to be paid. He's a humanoid robot with an important goal. He wants to become a teacher. Today he's teaching geography, and these are his first pupils.
Social bem-vindos.
They communicate with Now via camera and microphone. Today they're learning about sustainable development. Explaining facts is easy for the robot. But what makes a good teacher is empathy and understanding. How is a machine supposed to respond to children's feelings, or even motivate them? The scientist's first step is to analyze the behavior patterns that characterize the interaction between teacher and pupils. With this knowledge, Now can be equipped with emotional intelligence. To be able to act naturally, Now has to recognize his environment and the emotional state of his pupils.
Vocês são bons nisto.
Now is still a long way from human intelligence. All the same, his creators hope that he can start to form emotional ties with his pupils.
So what we're trying to do is to understand what role the robot can play. This means it's not important which robot it is, but we have a platform that allows to use different robots. You could plug in Pepper after a week of adaptation, or Buddy, or any of these things, because we think that it is very important to understand how the physical embodiment interacts with different ages, different cultures, and it's not just the robot. It's about knowing where you are in the game, the history of the child in interacting with the game, all kinds of information that maybe is in the background. So the robot is more of a puppet in this case. The function of this is to create a social emotional bond and use empathic cues to understand when something does not go well, to change the pedagogical strategies to achieve a certain goal. Will it replace teachers? No, but there are certain types of repetitive tutoring that can easily be taken by something like that, where a teacher does not have the time to spend with each and every child. Okay.
Fantastic. Thank you. I apologize. That was Dr. Kappas, Professor and Dean at Jacobson University. So we're going to round things off with interactive text with Davidson from Discovery Education.
Okay, this is going to be fast. Thank you. Clicker is under the hat.
There you go.
So Discovery is the channel that pushed broadcasting 30 years ago. Now we're trying to push fixed medium of print in schools. We've got about 30 million kids using our stuff now. About 40% of the UK is doing it. And we've got a lot of these elements built in already. We've got some gamification stuff in here. It's not nearly as good as what Filament has, but Dan and I are talking, so that'll be good. We have some AR stuff in here. This is Barbara Bush, former First Lady. This was in January of last year. She has a literacy event, and kids read There's Me because kids from all over Texas went to a Google Doc and built an augmented reality layer on top of the book. So any parent, any person with a tablet or a phone could see a whole new book on top built entirely by kids. But we think that the real weight of this is going to be in core curriculum material. So this is a math book, and I hope we have the sound up, because this book
why phone numbers in the United States
will read
including
to the
area
student.
codes
If you're a
contain
teacher,
10 digits.
this is huge. The ability for a math book to read. Because you can't decode,
do you think
you
10
can still
digits
do
will be
math.
enough to ensure that?
This is a science book. You can toggle from English to Spanish. You can go to French. You can, in a digital world, change the core book and the language just by clicking. This book will run on a cell phone, on a Dell, on a Mac, whatever you want. So that's how we're doing it. And there's not time to listen to this kid's testimonial, but if you're a student who can't read, you are in trouble by the 3rd grade and you are lost by the 9th grade. This is a student that says, this really helped because the book read to me and I could catch up. Now, we not time to hear that, but that's how this stuff works. This is, I think, just as important. You can change the font size. You can also change the reading level. So when you're in the 9th grade and you read at the 9th grade level, that's terrific. If you read at the 3rd grade level, you don't feel so good, except if your book will transform itself to your reading level. So that's a very big deal. The other thing that's kind of nice is that there's a reading level change. Click. Is in a social studies book, this is a social studies book, you have events that happen today. Because it's a cloud-based book, the results from the Iowa caucuses will be in the teacher's book the next week. So it makes real sense in social studies to be able to do that. These are how a teacher could scroll down and actually find events that happened in the last week, so that's pretty cool. The most fun thing is in math, I think. I taught math for 10 years in a classroom. This is an app called PhotoMath. It's not ours, but it means that a kid can open up a textbook and find the answers to his homework just on his phone. So when you have this technology in kids' pockets, you better not be relying just on the text in a book. So this is one of our math books, and it's manipulative based, which means you can drag the Pythagorean triangles around. You can actually change formulas and watch the way it works without having to do just the fluency. Is that my time? Am I that far over? Okay, just the fluency. So you can go into the concept of math, and we think it's going to make a lot more people love mathematics than love it now. So that's what we can. This is, again, changing the variables in a parabola, which you can do without having to graph every parabola. You just change the variables. You can see the variables up in the expression there, and you can change it and see what happens if a comet comes, et cetera, et cetera. So these are the advantages of the digital world. We think it works really well. We've got 1 million kids just using digital books. And here's the summary when I talk to school boards or talk to parent groups. What is this? This is a football game. Thank you, I'm from Los Angeles. And you see all the information there, the scores and what the first down is and all that stuff. And if you're trying to learn how to play this game because you're from New Zealand, this is a good way to learn. We want our kids to have these advantages of the digital age so they don't have to watch this on their television sets or the equivalent on their textbook. So thank you very much.
Fantastic.
Thank you, buddy.
Thank you. Thank you. Well, great. So before closing, we do have a couple of minutes left for questions. So if there are any questions in the audience, we have some mics here for the panel, for the panelists. Say it again? What does that mean?
You mean who we are?
Oh.
That's a good one.
Next time.
Let's see what we got here. Where does this go?
We can introduce ourselves again. Why don't we start down there? What do you think?
Sure. Let's just
So
do
I'm
that.
Steve Carlin with Aldebaran Robotics. Dan White, Filament Games.
Drew Minock with DAQRI.
Paul Davidson, Discovery Education.
There we are.
Arvid Kappas, Jacobs University for the Emote project.
Oh, there we are.
There we are.
We look good.
There we are.
Look at those handsome devils.
That was fast.
Sorry. Ready for questions?
We live in Wisconsin, that's all right.
Hi, my name is Don McMahon. I'm from Washington State University, and I do special education technology research.
Can you stand up? Can you stand up, please, so we can
Yeah.
see you? Thank you.
I'm from Washington State University. My name's Don, and I do special education technology research in AR. And I was kind of curious to see if, with the AR stuff that you're seeing, are there good platforms, or do you think there'll hopefully be winners emerging here soon for community-based options? Like, I love the helmet, and I just need a little smaller form factor probably for my students with Down syndrome out in the community, though. So,
In terms of community, is that what you said?
yeah, so they do, like I've done mobile phone AR where let's try to get to the grocery store because we're trying to teach you community-based navigation, or here's a femur and let's have, I use a RASMA, like Discovery Education did, it looks like, to make vocabulary words come alive. So to teach someone science vocabulary with a disability. But right now it kind of seems like it's the wild, wild west of AR. So.
Yeah, for us anyway, we have a platform called 4D Studio that allows the users to really create robust and powerful experiences in a very easy fashion, which will be, the updated version will be available later this spring at our event called 4D Expo. So that'll be one way that you could create your own experiences and then have the kids experience them that way, or better yet, have the kids create experiences if possible. Yep.
We got one right here.
Hi, my name is Dr. Eugene Kaufman, University of Phoenix. Quick question regarding the AR. How plausible is it to get them to all the university systems and just, I mean, financially wise, or even high schools or middle schools? Is it financially doable, or is it
Are we talking about the helmet?
Well, I mean, the phones don't really work very well in the classroom, at least in my experience. Kids just get kind of tired of it. But the helmet, I mean, I can see millions of possibilities.
Yeah, I think that's just the great thing about augmented reality in general, right? You're only limited by your imagination and the things that you can create with it. There's definitely ways that I could see the helmet being utilized in education down the road. Right now, it's solely industrial product that's used in that vertical, but I'm sure that there will be certain outreach programs to where we work with universities and things like that, but every school across the country, yeah, that'd be awesome.
There's an industry now that will do AR on your yearbook. So I was in Alabama, and the football team runs out of the cover. So and there's been a lot of schools, and I'm sure you have too, where there are pictures on the wall, and you hold up a tablet or a phone, or a parent comes in, they follow the right channel, and they'll see an explanation of what they do in the class, or this is my project, and this is why I picked Ben Franklin. So,
and piggybacking off of that, that's the power of the creation platform, right? Is that you can create your own content in the classroom to really bring learning to life, and view that through tablets or phones.
Okay, we're gonna have to move on from here. We appreciate the questions, and please do come up to the panelists. I think that they will be walking around, so you know their faces and their names. Just at this moment, we have to move on. It's been fantastic. We really appreciate you being here with us. I think that one of the things we need to start thinking about as we move these products forward is how do we dispense them to the classrooms, and also how we can empower teachers to help themselves understand what these technologies can do and how they can be afforded in the classroom. These are problems that I think we need to come together to start solving, and they really start here. They start here at organizations like this, where we can come together, speak to each other, connect, share resources and understanding together. So thank you for having us. We appreciate it.
Great.